Okay, so for today's lecture, I wanted to continue in Unit 3 with I/O management, really with the focus on the Java I/O package, that API. And so I'd like to kind of continue what we were kind of discussing with byte streams, input and output streams. So the next stream that I really wanted to go ahead and highlight is the data input stream. And so a quick overview for this presentation. We'll do a little bit of introduction for the data input stream. We'll talk about the data input stream's class declaration, its constructors, its methods, and some source code. So we can distinguish it from the other byte streams we've looked at and try to identify when it would be appropriate to use a data input stream. So to kind of introduce and motivate the concept, a data input stream in Java is a filter input stream. So a filter input stream itself is a special type. We've seen another subclass of filter input stream previously with a buffered input stream. So now we're going to look at another one, a data input stream. We won't spend too much time looking especially just at the filter input stream, because really it's designed to be subclassed by these other classes. And I want to spend more of my time looking at the other classes, but just understand that a filter, anything that is a filter input stream, effectively takes another input stream as a parameter in its constructor, and it provides more functionality to it. So when we refer to filter input stream, that's really what we mean. And so a filter input stream provides methods for reading a Java's standard data types. And so that's going to be the special thing about this particular one, is that we can use it for supporting Java's strings, for supporting all the primitive data types such as int, float, long, double, whatever from the stream. So the Java data input stream reads bytes from an underlining stream because it is a byte stream, and then converts them into the suitable primitive type value or string inside of our Java application. So it reads them to its underlining byte stream and encodes these values in a machine independent way, because again, one of the nice things about Java is that we're operating through the JVM. And so the basic input stream provides read methods only for reading bytes or characters. If we want to read the primitive data types, we have to use the filter class's data input stream. So that's the distinction between the input stream, the basic input stream, and what we get from this one. So here we can start actually reading our primitive data types from the stream, as opposed to just getting a byte or a character at a time. So the data input stream class works as a wrapper on the existing input stream to filter the data from the original stream. And again, that's what we refer to when we talk about the filter input streams or the filter output streams. So the data input stream class declaration, well, it extends the filter input stream that itself extends the input stream, and it implements the interface data input that has the methods that we need to go ahead and translate the contents of the stream into Java data types. And so here we see what the actual declaration would look like here. This has been a part of Java since Java 1 and is present inside the java.io.dataInputStream package. So that's what we would import if we want to access and construct a data input stream. So let's take a look at some of the constructors. Well, the class defines only a single constructor in Java, and it's as follows. We have a data input stream. It would take in an input stream instance, and from that, it creates that data input stream. So it uses, the underlining input stream and then adds that additional functionality on top of it. And so if we want to look at an example here in actual code, imagine if we had created a new file input stream, and suppose inside of our file, we would pass in some string that represents the file name, and that would then instantiate for us an instance, and we would store a reference of that instance here. Then we could use that file input stream to build the data input stream around it. And we would create a constructor, and then we'd save that new reference. And just like with the other filtered input streams, as we close the filtered input stream instance, so that's either the data input stream or the buffered input stream, it closes all of the inner input streams that it manages over. So to give you kind of a visualization of what's happening here is, suppose that you have like your file data here. So if I were to create a new file and then pass in my my pathway for that file as a string and then save that as a file object. And then I can go ahead and then create a new file input stream to be able to read from that file. So I pass my file object into the input stream, the file input stream, and I would save a reference to that. And then I'd pass that file input stream into my data input stream and save a reference to that. So you can see, here's my file object that I built a file input stream around, and here's my data input stream that I built my file input stream around. So you can think of a file wrapped with a file input stream, which itself is then wrapped with the data input stream. And again, a data input stream could be used for reading binary files. We're still talking about byte streams here. So in addition to methods inherited by the input stream and filter input stream superclasses, the data input stream classes use all the methods defined by the data input interface that makes it unique. So these methods read a sequence of bytes and they allow you to convert them into values congruent with the primitive data types inside of Java. And so here's a list of the important methods that we should just mention that are provided to us by that data input interface that we had mentioned. So we have the ability to read Boolean. And so that's going to return back a Boolean. And so what this is this method reads the byte from the stream and converts into a Boolean value. It returns true if the byte is non-zero or false if the byte is 0. We have read byte, which returns back a byte. This method reads a single byte from the contained input stream and returns a signed byte back from the input stream. We have the ability to read a short value. So this method returns 2 bytes because shorts are 2 bytes in terms of their encoding and returns back a short value. So this returns back the short from the input stream. Here we could read a car from the input stream. This reads in 2 bytes from the contained input stream and returns a car value. Read int reads 4 bytes from the input stream and encodes it, returns it as an integer value inside of our Java application. Read long allows us to read long values. That's 8 bytes that it pulls from our input stream and returns that back as whatever the long value is from those 8 bytes. Read float will read 4 bytes and converts that into a float value and returns that from our input stream. Read double allows us to read 8 bytes from our input stream and convert that into a double value. Read UTF is a method that reads the length of the string and reads and returns the string that has been encoded using a UTF-8 format. And so that this allows you to read strings. Skip bytes takes in an integer parameter of n and will return back an integer. And so the method skips over that specified number of bytes inside of your input stream without reading them. Read fully, where you can pass in a byte array. This method reads the bytes from the input stream and stores them into the buffer array. So very similar to some of the other input stream methods we've seen before. And then we have a read fully, where you can pass in a byte array, and then you pass in an n and an m value, both integers. And this method reads m bytes from the array, from the byte array, starting at the nth byte. So this is your offset, and then this is the number of bytes you want to go ahead and read. And just like all of the other IO stream classes we've seen, the throw an exception named IO exception, which is a checked exception. So whenever we use these methods, we either have to throw an IO exception from the method we're using them in, or we have to declare a try-catch block. So always keep that in mind whenever you're doing any IO processing, that it can always result in exceptional behavior. So we want to ensure that we either do the try-catch or we throw an exception so that whatever the client, our method is, can potentially try to catch it. Okay, let's look at some example code from the data input stream. So for the first example here, I'd like to write and read some primitive data to and from a file. So let's take an example program where we will write primitive data types into a file, then read data from the file and display them on the screen. So let's take a look at the source code here. Yep. And in fact, what I'm going to do is, let's actually go here. This is data input stream tester. Let's go into our IntelliJ, our IDE, and actually walk through this code, and then we'll go ahead and run it. So here, I'm going to import my data input stream concrete class, and we are going to also import the data output stream concrete class, because we're going to read and write our data from primitive data into the input and output streams. So we've talked at length about the data input streams. Next, we'll talk at length about the data output streams. We're also going to import some file input stream and file output stream, because again, this is a filtered, this is based off the filtered input streams. So it requires us to use a input stream as a parameter to construct an instance of either the data input stream or the data output stream. Okay, I'm also going to go ahead and import the IO exception. And instead of using a try-catch block, I'm going to just have the main method throw that IO exception to show you an alternate way that we could be defining our main method as opposed to using the try-catch blocks. And of course, we're just defining a class so we can have our main method so we can execute it. So inside here, I'm going to create a string variable I'll call file path. I'm going to create a path that's going to lead to a file called mydata.dat. .dat short for a data file. And here I'm going to create a new file output stream, and I'm going to pass it that file path. And we're going to go ahead and create an instance that is a file output stream on that file path. So we're going to write to that path, mydata.dat. Okay. So what I'm going to do then is, so the next thing I'm going to do is I'm going to go ahead and write to the output stream this UTF string. So a string I can write to the output stream with write UTF. And again, we'll look at this in just a moment, but you could see pretty much all the ways we do reads is the same way we do writes. So we can take an integer value and write that into our output stream. We can take a double value and write that to our output stream. We can take a Boolean value and write that into our output stream. And finally, we can take just a character and write that into our output stream. So these are all the different types of primitive data types and strings that we can use a data output stream to write to. Then what we're going to do is we're going to close our output stream, and that'll actually write that file. So in fact, if I delete this file, you can see it's going to create that. Now let's delete that, and that'll create that. Let's do that refactor so it doesn't exist anymore. And now that it exists, I'm going to go ahead and open that file up using file input stream and that file path that we originally defined here on line 8. And then we're going to use that file input stream and actually construct around it the data input stream so that we can read the primitive data right back off of this file. So here I can then from my data input stream read that string, read UTF, one of the methods we talked about, and we'll print that to the console. We'll print that into our, and then we'll read the int and then print that to the console. From the input stream, we'll read the double, we'll read the Boolean, and finally we'll read the character. And then after that, we'll close our input stream because we always want to close our streams when we're done operating them. So here, if I run this, what we should see is we will create that mydata.dat file. Right here, you see it created in the first staging of this application. And in the second staging, we will then open that so that we can use the data input stream to actually read these variables out. And you could see I was able to read a string, I was able to read an integer, I was able to read a double value, and I was able to read a Boolean, and I was able to read a char value. And so that's just a example. Yep, we have defined everything we just did there. So that's just a quick example of the data input stream. And so instances where you might want to consider using a data input stream is if you do have a file that contains data that you want to treat as primitive data types inside of your Java application. This is a good methodology for using that, being able just to open up that file, that data file, and being able to parse into primitive data types or strings into your Java application the contents of that file. Excellent. Does anyone have any questions about the data input stream?